5. Okay, so this is using a residual plot and a Minitab graph or Minitab data analysis thing here. And we're going to use that for 3 through 5. And these three are particularly tricky, I think. So hopefully I can square you away on this a little bit. So they're talking about fish and the activity level of fish given a particular temperature in Celsius. The fish activity was rated on a scale of 0 to 100. I don't really understand what that means. I don't know how you judge that, but anyway, they judged it somehow. And we have this data, like I said, residual plot and the data here, and a couple of the bits that are really important here. We've got the y-intercept and the slope, the r-squared and the s, and we're going to use all of those in these problems in one time or another. So what is the correlation between temperature and fish activity? It would be really easy to jump to 91% as 0.91, but that's not correct because correlation is r. Not r squared. So what I'm going to do is I'm going to take that r squared value and I'm going to turn that into a decimal, and I'm going to take the square root of that. Okay? Now, once I've taken the square root of that, I'm going to get about 0.95, and then I can go looking for my answer and go, oh, it looks like it's A. But I would be wrong. It's not A. What you have to take into consideration on this is, was that R positive or negative? We don't know that unless we look at something else, and that hint comes in the slope. So the slope is negative. Now, if I go back to this formula that we learned the other day, B equals the slope equals R times S sub x over S sub y. One of the things that I love about stats is every year I learn something new, or I clued into something new, or I get it at a different level. And so one of the things that I clued into, or was sort of clued into by one of the students, was that the standard deviations are positive. If these are both always positive, the only way a slope can be negative is if r is negative. So what that tells me is that this is actually a negative 0.95 to get me this r squared value of 0.91. So the answer here is E. Tricky. Tricky. It's detail. And as much as I'd love to put every last ounce of detail that's possible in my notes, I don't know that I can catch all of them. So this is a good time to kind of catch some details. For what it's worth, I don't go looking for test questions that are going after that. So for 3.4, or 4, what's the actual activity level rating for the fish at temperature of 20 degrees Celsius? The actual is the key here, and activity level is what we're talking about. So if I go back up here to my residual plot, this is activity level, and then this is going to be change from what we expect for the temperature. So if we're right on the line, then the temperature is exactly what we expect for the activity level given. Okay, so how do I get this for 20 degrees? Well, what I need to do is I need to take my Minitab information. I need to write my equation. So y hat equals 148.62. That's the constant coefficient, which is the y-intercept. In this case, minus 3.2167x, where x is the temperature. Excuse me. Okay, so I'm going to plug in 20 for there, so I'm going to bring my calculator over. And I'm going to say 148.62 minus 3.2167 times 20. And I'm going to get about 84. I'm going to round that a little bit. We're going to call that 84. So we expect the activity level to be 84. So y hat at 20 is going to be 84. But this is asking for the actual, and I bet you anything 84 is one of the answers. Sure it is, it's B, but we don't want B, we want the actual activity. So what that means is we've got to go up here to our residual plot, and I'm going to look and I'm going to try to find 84 as best I can. It looks like that would be this dot right here, and this dot is above what we expect, and it's above it by about 3 degrees, maybe a little bit more than 2.5 degrees. So if I take my 84 and I add that 2.5 to 3 degrees, or actually it's not degrees, sorry, it's the activity level. Again, whatever that measurement is. So now I'm going to go back here and I'm going to look. Do I have around 87 as a choice? It is. 87 is A. So 3.4 is A, and we need to go a little bit deeper than just plugging it into the equation. It's that actual is the key word there. All right, moving on to 5. Which of the following gives a correct interpretation of S in this setting? So we're talking about the least squares line of regression. That's what we're dealing with here. Now they didn't give us the least squares line of regression, but they did give us the equation. And it's a negative slope. And they also gave us S in this scenario. So let's read through this and see if we can figure out what's going on here. So for every 1 degree Celsius increase in temperature, the fish activity is predicted to increase by 4.785 units. Well, that would be true if S was slope. But it's not. It's standard deviation. So if this was giving the slope value, I'd say sure, that's great, but it's not. B, the typical distance of the temperature readings from their mean is about 4.785 degrees Celsius. I like the word typical, but the problem is this is not measuring temperature, it's measuring fish activity. So they've basically got the X and the Y mixed up on this. So they're referring to the X-axis when they should be referring to the Y. So it's not B. All right. C, the typical, there's typical, I like that again. Typical is a good word that goes with standard deviation. The typical distance of the activity level ratings from the least squares line is about 4.785 units. I like that one. I'm going to read through the others just to see what they say. The typical distance of the activity level readings from their mean is about 4.785 units. Both of those have some, could potentially be the answer. And C, at temperature of 0 degrees Celsius, this model predicts an activity level of 4.785 units. I think at 0 degrees Celsius, my fish activity level would be 0. I don't know about you, but all my fish would be frozen at that temperature. Okay, so it really comes down to between C and D. Which one's the better answer? The better answer is C, and here's why. We're talking about a line of regression. It is got a negative slope, and basically what this standard deviation is doing is we are above this line by about 4.875 units, or about 4.9 units, and we are below that at about negative 4.9 units. And so 68% of our data should fall between these, and the rest of it should either be above or below. In fact, it should be equal amounts above and below. So the best answer here on this one is C. It is typical distance from the least squares line. Anyway, I hope that helps.